Okay, so we're going to start by figuring out what the problem wants us to do. So we have a 75 milliliter solution of HCl, so we're going to highlight that, with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of CaOH2. So we're going to highlight that. And then this last sentence tells us what we're trying to find. What was the concentration of HCl in the original solution? So we're looking for original HCl concentration. So to start things, we need to know our balanced equation. So we have HCl plus CaOH2, CaOH2, and that's going to result in H2O and calcium chloride. And then now we need to balance it, so we'll have two H2Os and two HCl's. So now that we have our balanced chemical equation, we can draw our particle picture. So for our HCl, we know we have 0.75 milliliter solution of HCl. So 75 milliliters, but we don't know our concentration, so we'll put a question mark, molarity. So then, since this is a strong acid, it will be in ions, so we'll draw it like this. And then now we have to draw our CaOH2 as a particle picture. And so we know we have 27.3 milliliters, 27.3 milliliters. And then so we have Ca, which is a 2 plus, and our OH minus. So we have to have 2 OH minus. And we know our molarity is 0.157. So, all right. So now that we have all this, first we need to convert our milliliters to liters, because that's one of the first big common mistakes. So we have 75 milliliters equals 0.075 liters of HCl. And we want to do the same thing with our CaOH2. So 27.3 milliliters equals 0.0273 liters of CaOH2. So now that we have that, we need to remember our stoichiometry. So if we have the volume and molarity of a substance, we can find its moles. So first we'll do that. So we have our 0.0273 liters times our 0.157 molarity CaOH2, and that right there will give us our moles, which is 0.004281 moles of CaOH2. So now if we remember stoichiometry, we know we can find our moles of HCl. So we have moles of CaOH, so we'll rewrite that down here. All right, and then so we look up here, and 1 mole of CaOH equals 2 moles of HCl. So this is moles of CaOH2. And so then we'll to simplify it, we need our 1 mole of CaOH2 on bottom and our 2 moles of HCl on top. which will give us our moles of HCl, which is 0.00857222 moles of HCl. So now that we have our moles HCl and we already have our volume, so moles per volume equals molarity. So we just have to plug our numbers in to get our molarity. So 0.0085722 moles of HCl equals, over our 0.075 liters. And that gives us our molarity, which is 0.1143 molarity of HCl. So that's how you go from the volume and molarity of one of your reactants to find the molarity of your other reactant. So 2 big common mistakes would be to forget to convert your milliliters to liters, and that you can go use stoichiometry to find the moles of one reactant from the moles of the other reactant.